Okay, so we're looking at the thickness of a textbook. If you don't have any textbooks to measure, what's the thickness? 0. 0 millimeters, right?
Oh, yeah.
One textbook. What did you measure is the thickness of one textbook in millimeters? Yep. Yep. 25 millimeters. What happens if you stack another textbook on top of that? Yes. It would be 50 millimeters total. What's happening every time you stack a textbook? Yes.
Adding 25.
We're adding 25 millimeters. Does that make sense?
Yes.
Is it increasing by the same amount every single time?
Yes.
So what is the rate of change? What will, when we graph this, what is this going to increase by every single time? 25 over 1. For every one textbook, it increases by 25 millimeters. Does that make sense? So fill in the rest of the table. Okay, so as you can see, we've completed the table up to 9 textbooks. What would be the independent variable? And which one would be the dependent variable? Think about it.
Dependent.
That the dependent variable would be the thickness, and the independent would be number of books, of textbooks, which means that if it's independent, this would be X and this would be Y. Does that make sense?
Yes.
Does the thickness of the textbook depend on how many textbooks you have?
No.
Yes. The thickness depends on the number of textbooks. Whenever, the reason that it helps to identify the independent and dependent variables because then you know where to graph this on the graph. So you're going to graph it now. What would be a good scale to choose for your x-axis? Look at your values. What would be a good scale to count by? 1. Sure. And what would be a good scale to count by for your y-axis?
50.
Yeah, you can count by 25, so it would be easy to graph this. Okay, so we're plotting number of textbooks on the x-axis, right? Number of textbooks, and what's on the y-axis? Thickness in millimeters. You don't have to put the units on the axis because we've indicated it in the label. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I can even put 10 here. We know that if we have 0 textbooks, then the thickness is 0. We're not measuring anything. So the first point is going to be right here. This is called the origin. 0, 0 is called the origin. You're going to use that word a lot, okay? So copy that word down, origin. Okay, so I plotted all the points. If I were to extend this graph, can we make a prediction? If we had 10 textbooks, using the graph, what would be the thickness of 10 textbooks stacked together? According to this relationship, what would be the thickness for 10 textbooks? 250 millimeters would be the thickness for 10 textbooks. This point is at 10, 250. Okay, so first question says, what is the starting point of this graph? Where does it start, Raphael? Where does the graph start?
Well,
the origin. This is the starting point. So your answer, you can write 0, 0. Write the coordinate as well. Next question is the relation linear? How do we know if a relation is linear? Raise your hand if you think, yes, this is linear. How do you know? Yes, it's linear. How do we know? One way, so you can copy this down. Yes, it's linear because the points form a straight line. Excellent. How else do you know it's linear? Yep. Increases by the same amount. That's definitely a way that you can tell if it's linear. If it's increasing or even decreasing, it can increase or decrease, but as long as it's increasing or decreasing by the same amount, you know it's going to be linear. It has a positive trend. Yes, it can. A graph can be linear if it has a negative trend as well, but the point is there is a trend here. There's a trend in the data. It's increasing by the same amount every time. And what can you tell me about the rate of change? Is what? Does the rate of change, does it change every time? So the word we would use is constant. It's constantly increasing by the same rate every single time. It doesn't, the rate of change doesn't change. And that was a question I mentioned earlier. What is the rate of change equal to? What does this increase by? And we can pick 2 points. We can draw a triangle. Let's do this. Let's pick these 2 points. Here's my rate triangle. According to the 2 points I picked, what does this go up by? What does it increase by? From 25 to 100, what does it increase by? From 25 all the way to 100. 25 plus 25 plus 25. What is it increasing by? 75, right? That is my rise. We did this yesterday. And what is the run? From here to here. 1, 2, 3. Good. And we can use the slope formula as well. We learned that yesterday, plugging in y2 minus minus y1 over x2 minus x1. Let's reduce this. What's 75 over 3? What's 75 divided by 3? 25 over 1. Does that make sense? Go back to your table. What does it increase by for every 1 textbook? How many millimeters is it? 25. The rate of change is 25 over 1, which means that 1 textbook equals 25 millimeters. A textbook, the thickness is 25 millimeters. What they've told us now is that this relation is called a direct variation. This is the first time you're hearing this term. We're going to read the definition of it, and we're going to talk about why this relation is direct variation. So what is the definition of a direct variation? Okay, so before we discuss the definition, let's come up with an equation that could show the relationship between the thickness of a book and the number of books. We need to come up with an equation that shows you how to calculate it in this scenario. How would you calculate the thickness? The thickness here is the thing we're calculating. That's the dependent variable, right? We're calculating the thickness. I'm going to call thickness T. So I'm giving you a clue here. We're figuring out how to calculate the thickness of a textbook. Yes?
Wait, so
We're going to say N represents number of textbooks. That's great.
25 times.
And how do you calculate the thickness? What do you do to every time you add a textbook? You multiply by 25. Is that true? If I wanted to know the thickness for 10 textbooks, for example, that was the one that we inferred on the graph, what's the thickness? What's 25 times 10? Was that true? Where 10 textbooks was the thickness of 10 textbooks 250 millimeters?
Yeah.
Millimeters? Yeah. So this is the equation. To calculate the thickness, we would take 25 because that is the rate of change. That's how it changes every time, and we would multiply it by the number of textbooks. So, definition of direct variation. When the dependent variable, in this case that's T, is a constant multiple of the independent variable, in this case is N. It's a constant multiple. It increases by a number every single time. There's no other factors involved. There's no other additional numbers that we would have to add to this. It's just a direct relationship between thickness and textbooks. Does that make sense? Yes. So the constant multiple is the rate of change, like you saw here. Okay? And this is an example of the formula you would write. In this case, T equals 25N. Okay? They're just telling us that this value here before the N is the rate of change. Was that my rate of change, the number in front of the independent variable? Okay. Is the graph linear? Does it pass through the origin? Was the initial value 0? Okay, that's how you know if a relationship is direct. So to sum it all up, if it starts at 0, 0 and it's linear, it's direct. Okay, if it does not start at 0, 0, let's say it started here, this is not a direct variation. You're going to learn what that is another day. But for today, you just need to know that anything that starts at 0, 0 and is a straight line will be a direct variation.